Did you know that over 80% of cancers detected in stage 1 eventually go into remission? Early diagnosis saves lives. So why aren't we detecting more cancers early? Current tests are invasive and expensive, so we mainly test for cancer only when symptoms start to appear. But using blood-based biomarkers can help us change that paradigm. I decided to focus on cell-free microRNA, which are small pieces of genetic material that tumor cells actually leak into the blood. But the problem with using cell-free microRNA to detect the presence of cancer is that there isn't enough data on cell-free microRNA. There's really only 5 published geodatasets on cell-free microRNA for cancer. So my plan was to train a classifier on tissue microRNA from TCGA, then use deep transfer learning to make this classifier work with cell-free microRNA. I used different machine learning methods in order to classify tissue microRNA and eventually achieve 97.2% accuracy. I then built a deep neural network, a denoising autoencoder, and I used different methods and eventually taught it to encode both TCGA data and tissue cell-free microRNA data into the same 32-bit representation. Lastly, I tested this classifier, tested this transfer learning based model on cell-free microRNA, and got great results. So 0.88 AUC, 91% overall. This is great, and I think these results are really unprecedented. It would not have been possible without my novel transfer learning based approach. And I think this kind of method is the future. You can have some kind of QIAGEN test to detect cell-free microRNA in blood, and then use those expression values to actually diagnose cancer, pick out the signal from the noise. I also made a web-based tool, and you can read about it inside the results section. Thank you.